We're sharing moments from the 2025 Humans to the Moon and Mars Summit, this week on Planetary Radio. I'm Sarah Al-Ahmed of the Planetary Society, with more of the human adventure across our solar system and beyond. This week, we're bringing you highlights from two powerful panel discussions recorded at this year's Humans to the Moon and Mars, or H2M2 Summit in Washington, D.C. Both were hosted by our Senior Communications Advisor, Mat Kaplan. We begin with a conversation about why space science is vital to U.S. national interests, featuring insights from James Green, the former NASA chief scientist, James Garvin, chief scientist for NASA's Goddard Space Flight Center, Britney Schmidt, astrobiologist and associate professor at Cornell University, and Nobel laureate John Mather, who's also the senior scientist for the James Webb Space Telescope. They'll explore how scientific discovery drives innovation, strengthens international partnerships, and helps us understand our place in the universe. Then we'll turn to the power of diplomacy in space with a panel on the Artemis Accords. We'll hear from Mike Gold of Redwire, Mark Jokic from the German Aerospace Center, or DLR, Adnan Mohammed Al-Rais from the Mohammed bin Rashid Space Center in the United Arab Emirates, and Sohair Salam Saber from the Hague Institute for Global Justice. They discuss how international cooperation is guiding humanity's return to the moon and our journey beyond. Then stick around for What's Up with Bruce Betts, our chief scientist, as we talk about what we'll lose if the Gateway Lunar Space Station is canceled and how that impacts the plans for getting humans to Mars. If you love Planetary Radio and want to stay informed about the latest space discoveries, make sure you hit that subscribe button on your favorite podcasting platform. By subscribing, you'll never miss an episode filled with new and awe-inspiring ways to know the cosmos and our place within it. Before we take a trip to this year's H2M2 Summit, don't miss our recent bonus space policy edition on the proposed U.S. federal budget for NASA in the fiscal year 2026. Casey Dreyer and Jack Corelli from the Planetary Society were joined by Alicia Brown of the Commercial Spaceflight Federation and Brittany Webster from the American Geophysical Union. You can find that bonus episode on our website at planetary.org/radio or wherever you get your podcasts. And don't forget, a regularly scheduled Space Policy Edition returns this Friday, July 4th. Now we take you to the 2025 Humans to the Moon and Mars Summit. This annual event hosted by Explore Mars has expanded beyond its original Mars focus to reflect the current trajectory of human space exploration, returning to the moon as a stepping stone to the Red Planet. Held in late May at George Washington University in Washington, D.C., H2M2 brings together space leaders, policymakers, and scientists to build consensus and turn bold ideas into action. If you'd like to watch the full videos of these panels and others at the summit, you can find them on Explore Mars' YouTube channel. We've also included a link to the full playlist on this episode page at planetary.org/radio. This first panel is called Space Science, a Vital National Interest, and explores how scientific discovery shapes U.S. national priorities and why the current fiscal moment could endanger decades of progress. Joining this panel were four remarkable voices in space science. Dr. James Green served as NASA's chief scientist and now chairs the advisory board for Explore Mars. Dr. James Garvin is the chief scientist for NASA's Goddard Space Flight Center and a longtime leader in Mars science, having helped define NASA's Mars exploration strategy since the early 2000s. Dr. Britney Schmidt is an astrobiologist and associate professor at Cornell University, known for her pioneering work on ocean worlds and planetary habitability. And Dr. John Mather, a Nobel Prize-winning astrophysicist. He led the science team for the COBE mission that helped confirm the Big Bang by measuring the cosmic microwave background, the faint afterglow of the early universe. Now he serves as senior scientist for the James Webb Space Telescope. And of course, you'll hear from Mat Kaplan, the creator of Planetary Radio and our senior communications advisor who hosted this panel.
To attempt to understand the cosmos, to answer those two great questions, where do we come from and are we alone? Is there a greater quest than that, or is there one with a better return on investment? Yet, every few years, our leaders lose sight of the value of science and exploration, and it would seem that we have entered perhaps the greatest period of that challenge in our nation's history. And that's why I'm really so honored to help open this year's Humans to the Moon and Mars Summit and to welcome these four superb scientists. Jim, help us get started.
Well, thank you very much, Matt. What I'd like to do is sort of set the context of why we need a scientist to be able to talk about what we do, get the knowledge out. And it's because of the federal funding that we receive that allows us to do these spectacular things. Well, the president has issued what was called the skinny budget. And in this particular budget, there is a mark for reductions, not only in earth science, but in the space sciences. And this reduction is quite large. It reduces planetary by $3+ billion out of the $7.8 billion that it currently has. SMD will take a $3.4 billion decrease. That's 47% of the budget. And it's broken up in two pieces. One is the earth science piece, which is a reduction of $1.2 billion, with direction on cutting back or eliminating funding for lower priority climate missions. In the space science part of the budget, space science should be thought of as those four divisions. That's astrophysics, heliophysics, planetary science, and the biological and physical science division. That is a reduction of $2.3 billion with direction on canceling Mars sample return. Now, the management principle NASA uses has to be understood in terms of how do you take a cut that's so large, how do you look at that portfolio and decide what are you going to cut, what are you going to keep, and each of the divisions really work hard to create a balance. There's a certain approach associated with it. If you're going to start cutting missions that haven't been launched yet, this really hurts those missions that are in the development phase if they're not going to make it. And in planetary science in particular, that's incredibly difficult because we have windows we have to meet. And if you delay a mission, sometimes you then can't do the mission at all. So there are large portions of the budget that will have to be taken with these kind of rules in mind, and everyone looks at the decadals. So these are the decadals. And in these decadals, there are some decision rules. And they're all pretty consistent. You know, here's an example of decision rules. And in this set, you see you cut out the strategic missions or delay them. You reduce your competed missions. Those will be the ones that are currently in the process of being developed. And then you delay your competitions. And typically at the very end is research and analysis because you have your community you have to support. And so this is also true in all the other decadals. There are certain associated rules for which saving the RNA program and keeping the community intact is the best approach. So in conclusion, there's going to be no new starts in strategic missions. That won't be possible. You know, this is why Mars sample return, which would be that next big strategic mission, has been canceled. You're going to be canceling some competed missions. Last in, you know, the last one you decided will be the first one out. You delay all newly competed missions because you don't have the money to fund them, even if you can make a selection. And then you have to somehow figure out how to shrink the national needs. So that has to be folded into this priority. So for the divisions, you've got operating costs like on the operating missions. You want to be able to support as much of the community as you can through RNA. But the cuts are so deep, half the budget, that even reductions in those areas will be expected. So that makes it a very difficult environment that we're moving into. And so with that, what's happening with our science?
So we will hear more specifically about science, beginning with our other Jim G., James Garvin, Chief Scientist for the Goddard Space Flight Center. Jim, take us to the Red Planet.
Well, thanks, Matt and Jim, for setting me up. I'd like to look through the lens of the universe of science Jim was talking about, through the ways it's been funded by leaders like him, and focus on Mars, because we're really in a very special moment right now. We're looking at 50 years since we first had the audacity to ask, are we alone, through what we could read in the record of Mars, before we had ever landed on any other world robotically other than the moon. And we did that literally 50 years ago with Project Viking, and learned a lot in the intersection of the science we choose to do, but also the engineering masterpieces that allow us to do that. And that's the legacy that lives on in all these programs that you heard from Jim. So let me just remind you what we did. We went to Mars 50 years ago with our eyes wide open in the possibilities of a very Terra-centric world. And that red Mars we see is not the Mars under a veneer of dust, as you'll hear later. We also saw cycles of what I would call the Mars meteorological system and the climate that we didn't even know were existent. And so Project Viking emplaced our engineering and technology power onto Mars to open that frontier. And maybe we didn't know what we'd find, but we discovered the engineering boundary conditions to give us, I would say, the boldness to go after new things. And that set in motion a new Mars exploration program about 15 years later that culminated in many things. But I wanted to remind you, science comes in different flavors. Sometimes the science we measure, and in this case, the topography of the planet Mars in a geodetic framework good to a meter everywhere, gives us enabling powers. Before we had the mission of the Mars Orbiting Laser Altimeter, the knowledge of where to land on Mars. I always use the analogy of landing on a carrier deck with uncertainty at the level of 1,000 feet. I'm sure the great air flyers, the naval pilots, would probably not like to know that about the deck position on landing on a great carrier. But that was where we were before MOLA gave us Mars in 3D at the level where we could see the whole planet, figure out aspects of its interior, and also see magical things like the crater Korolev seen there with a central mound of ice that rises above the rim of the crater. How does that happen? And these are some of the magical discoveries that a new technology that many said should not be done gave us the ability to see new things about a world that we've now been visiting and landing on successfully ever since that mission. We've also put in place the ability to do the recon for the future. And this is really important because the science questions require context. And you saw that in the workings of what Jim showed. And so we put in place, when we restructured Mars in around 2000, the idea that we would measure everything we could at all the scales that matter, including those that would enable sample return and humans, crew, women and men going to Mars. And so the Mars Reconnaissance Orbiter, now 20 years in its life in space, has done many great things. I can't possibly describe the voluminous papers that have been done, but one thing it did was it mapped every square inch of Mars on a 6-meter digital image framework. That, for the price of literally a small B movie, gave us the ability to put what we do on Mars today into the context of landing safely, driving where we want to go for all of Mars. So now the trade space of where we can go is open to the eyes of where we want to go, thanks to that mission and also the higher resolution data sets. So the Mars Reconnaissance Orbiter is an example of producing science in the context of the engineering boundary conditions to let us go to Jezero Crater, Gale Crater, to imagine climbing Olympus Mons with those giant escarpments that are a harbinger of how Mars worked. So this is just part of the legacy of the program. Some of the discoveries, and you're going to hear about those from Jen and Danny in the next session, are really transforming how we look at the planet. Not from just, let's see what we get, but to not just following the water, but following the organics as indicators of what it might be like to be there, work there, live there, and return stuff from there. And that connects Mars deeper than just one silicate rocky planet with a small atmosphere and a changing climate to the bigger cosmos that you'll hear about from John. One thing is, we know Mars is a dust world. Critical to its current evolution is its meteorology, if you will. And we see the dust storms on Earth beautifully seen here from the International Space Station. The Mars dust space is still the nano-Mars we don't know. That'll be a key ingredient to looking to go there ourselves, to living and working there. So I'll leave you with a couple thoughts. I think of Mars, as we leave our planet and go back to the moon with Artemis, as that doorway we will leap from. from that era, set up by these robotic missions we've been talking about, into a new era where Mars will connect beyond just going there ourselves, but through doorways to the bigger beyond. So thank you, and let me turn it to Britney.
Thank you, Jim. We're going to continue on out across the solar system now. If you ever have trouble reaching Dr. Britney Schmidt, it might be because she's a few thousand kilometers from the nearest cell tower. She's an associate professor in both the astronomy and Earth and atmospheric sciences departments at Cornell University. I'm also very proud to say that she chairs the Space Policy and Advocacy Committee for the Planetary Society's Board of Directors. Britney, it's all yours.
Thanks. It's a really an honor to be here today to talk to you about the solar system beyond Mars and its connection to the exploration of the Moon and Mars. So in these pictures I'm showing here are just some of the work that we've done, but we just represent only a couple of the programs that have been funded primarily through NASA's RNA programs, research and analysis. Programs through the astrobiology program that allow us to co-develop technology and deploy it here on Earth to test that technology and to get better science done by embedding engineers and scientists in the process. And that's exactly what we do here. So shown in these pictures here are our robot IceFin, which Matt just introduced, which is a technology development platform for future missions, hopefully to Europa. And while it was built by funds from NASA and universities, it actually has turned into being a big climate explorer for our own planet, participating in National Science Foundation research as well as international campaigns. So that's on the left side. So those are a few of the IceFin expeditions and some of the space missions that we've been able to inspire using our now understanding of how to explore the Earth, particularly in this rare place, hard to get to place underneath the ice. It turns out I actually do some Martian research, but it's also here in our backyard. And so this is PINGO STAR, which is my favorite acronym ever. But it's an exploration of the Earth's permafrost using technologies that might be applicable to future human exploration. So here we're dragging things like ice-penetrating radars and resistivity mappers to search for ground ice in the poles of our own planet. So it's helping us to understand how these processes work here for the very first time, as well as proving technology. And as I mentioned, all of this isn't funded through a flagship mission. It's funded through NASA research and analysis grants, and often through logistics through National Science Foundation. So last year I had the opportunity to sit and watch something I've worked on since I was a graduate student launch to space. So this is Europa Clipper, which is the work of tens of thousands of scientists across the United States at universities as well as NASA centers. Europa Clipper launched in October and will finally arrive into Jupiter orbit in April of 2030 and then move on to a multi-year tour of the Jupiter system. It was a really cool experience. It's our next big flagship mission, and the first one ever dedicated to the exploration of an ocean world. The ice-penetrating radars that have been sent to Mars and are now on its way to Europa were built here first and tested in Antarctica in order to study the Earth's climate. So what does this look like? So we've got these beautiful places, Greenland and Antarctica, and if you're less familiar with some of the research that's done there besides the Earth's climate, there's actually a ton of Mars research done there in the Antarctic dry valleys, which is one of the closest environments on our planet to that of Mars. How that really works is that the National Science Foundation actually funds both science and logistics that go to Greenland and to Antarctica to do the science there. The interplay of these agencies also really matters in the fabric of science and in turn the fabric of Mars exploration. In fact, most of the astronauts these days have been to Antarctica, or many of them. It's considered one of the great training grounds to work in these extreme environments. And so there's a whole bunch of interactions between these agencies that you might not be thinking about when you think of NASA and space exploration and humans going on to space. I want to highlight here that the National Science Foundation is also under extreme duress. NASA's facing 24% top line. The NSF is facing at least 49%. We don't have the details on that. But I'm showing here this recent article from the New York Times that shows that the Office of Polar Programs has already spent only 22% of what it would spend in an average year this year. So that's before this budget cut. We've already cut science and logistics in Antarctica by 88%. What does that look like? Here's what we did when we wanted to go to the moon. We put a whole bunch of money into it, right? And that trickled down. That actually did work, right? We funded all science because it's all interconnected, because all of these technologies and all of these innovative minds are the ones that will eventually bring us the technologies that we need. That's the backbone of our economy, the backbone of innovation in the United States, and a lot of it was born from the Apollo program. That's what we proposed to do there. Here we want to go to the moon, and now we want to go to Mars, an even grander challenge. And we're going to do it by cutting the budget. That should work out well. And here's the biggest lesson here is that the public supports this. So this is a recent Pew study that shows what people think NASA should be doing. At the top of that is monitoring asteroids to protect our own planet, monitoring parts of the Earth's climate system, and conducting basic scientific research. These are on the hit list during this budgetary crisis. So while we're hearing a lot about how we're going to direct science and engineering funding towards the moon and Mars, I just wanted to give you a picture of how we got to the moon and Mars in the first place, and how we might think about doing that if we can get back to a budget reality that makes some kind of sense. Thanks.
Thank you, Brittany. All right, we're going to head even further out into the cosmos now by hearing from John Mather. He was named MVP when he shared the Nobel Prize for Physics in 2006, thanks to his Cosmic Background Explorer spacecraft and what it revealed. John?
Well, okay, thank you. I'm glad you're all here to think with us about what can we do and what may come next. I want to show you some stories about what we've already been able to do and what we're thinking about. So here is a picture of the great James Webb Space Telescope. But you see the great golden hexagon. It's 6.5 meters, about 21 feet across. And we did that. It's an international partnership between NASA, Europe, and Canada. And we did that. About 20,000 people it took to do that. So one of the most amazing collaborations that I can possibly imagine participating in, and I got the privilege of speaking about the science to all of you for a long time. So thank you to the public who supported this. It's one of our biggest science projects ever, and it's been massively successful. Why do we do all these things? Well, where do we come from? It was already mentioned before. Well, astronomers have been working on this, and it's not only how do we study the Earth, but how do we get to that? Where did the Earth come from? Where did the sun come from? And here's the next question is, what do we, who are we? Well, that's not really my question to answer. Maybe philosophers will be able to answer that better. But we can, as astronomers, work on what is the cosmic history. We know about the expanding universe, which is mislabeled the Big Bang. And we've been working out a lot of the details of it, and we still haven't got it quite figured out because there's more to do. Biggest question that I've had, and I think many of us have had since childhood, is, are we alone? And as Fermi asked, well, where are they? And why haven't they been visiting? So, well, some people think they have. But at any rate, astronomers can work on the evidence, and we're trying to figure that out. We have been able to locate thousands and thousands of planets around other stars, and I'll show you a little bit about how we do that. And we're learning something about them. So far, no other solar system just like ours has been turned up. But maybe they're there and we just can't tell yet. Is life a miracle? Well, people used to think so. And now we're beginning to make a little bit of progress on the chemistry and the possibility of how it might have actually occurred here on Earth. People are working out the chemistry of how it might have happened. Well, how far can we go? Well, so far we've only thought of chemical engines that we can imagine, and solar electric propulsion, maybe the nuclear electric propulsion, and that cannot actually get us very far even in the solar system. It's a pretty big place we live in. So we put the Webb telescope 1.5 million kilometers away, which is only 0.01 of the distance to the sun. It seems like a long distance to send a signal than to do astronomy, but it's the right place to go. Mars is a whole lot further away, and the rest of the planets are farther than that. So you could imagine traveling to the rest of the solar system, and we certainly are going to think about how. So far we're sending robots. We've sent robots everywhere. We could, if we really, really tried, go farther than Mars. But that's hard, and it's pretty dangerous as the way we would do it today. So now I want to talk to you about this discovery of the early universe. So this is a map that got a Nobel Prize for us. When we heard about the expanding universe in 1929 from Edwin Hubble's graph that showed the rate of expansion, the distant galaxies running away from us. It took a little while to get to the calculation that said, in 1948, right here in this university, that there should be cosmic microwave radiation left over from those early times, and we ought to be able to see it. Well, in those days, it was too hard to do. Nobody went to look. In 1965, it was discovered by accident. People were working on the space program and trying to start up telecommunications by bouncing signals off of satellites. So that was at Bell Telephone Labs, and they said, well, no, there's a little extra noise in our receiver. What is it? And it turned out to be this. So now we have a map that shows the sky is not equally bright in all directions, but actually has hot and cold spots, which relate to the conditions in the very early universe. When Stephen Hawking saw this chart, he said that was the most important scientific discovery of the century, if not of all time. Thank you, Steve. So why is it important? It tells us the initial conditions as near as we can get to what is the universe like when it was very young. And if you could figure that out, you could say, well, in that case, we ought to be able to predict more or less what happened after that. How did the galaxies grow? How did the black holes grow? How did stars grow in the galaxies? Maybe how do planets grow from the stars and the debris of stars? All those things that we tell you, the story of our solar system, should somehow connect to this picture. So working out our cosmic history, our personal history, this is part of it. So we're learning. We will be able to tell you sometime, a few more decades, maybe a little more certainly, how something like the solar system could form. Now, the solar system is unique as far as we know. That's interesting. Let me just wrap up here and say there's much to find out. I'm really interested in the Mars program because it lets us find out the answers to things we could never do just by imagination. We could go pick up a rock like he has and say, I see that, I analyze it. Maybe we'll find one that has microbes in it. Maybe they're alive, maybe they're dead, but there's something. This is the first chance we really have to do that. So I'm hoping for the best.
Thank you, John. I don't know about the rest of you, but I would just sit up here on the carpet at their feet and just listen. Because to me, just what we've heard, which is such a tiny fraction of what has been delivered by the dollars that this nation has put into space science and space exploration, seems to be worth it on its own, just for the sense of wonder that it generates.
We'll be right back with the 2025 Humans to the Moon and Mars Summit after this short break.
Greetings, planetary defenders. Bill Nye here. At the Planetary Society, we work to prevent the Earth from getting hit with an asteroid or comet. Such an impact would have devastating effects, but we can keep it from happening.
The Planetary Society supports near-Earth object research through our Shoemaker NEO grants. These grants provide funding for astronomers around the world to upgrade their observational facilities. Right now, there are astronomers out there finding, tracking, and characterizing potentially dangerous asteroids. Our grant winners really make a difference by providing lots of observations of the asteroid so we can figure out if it's going to hit Earth.
Asteroids big enough to destroy entire cities still go completely undetected, which is why the work that these astronomers are doing is so critical. Your support could directly prevent us from getting hit with an asteroid. Right now, your gift in support of our grant program will be matched dollar for dollar up to $25,000.
Go to planetary.org/NEO, N-E-O, to make your gift today.
With your support, working together, we can save the world. Thank you.
Our second panel from the Humans to the Moon and Mars Summit explores how international partnerships are shaping humanity's return to the moon and our journey to Mars. The Artemis Accords are a diplomatic framework built on principles like transparency, peaceful exploration, and interoperability, guiding how nations work together in deep space. This conversation, called Artemis Accords, International Collaboration in Deep Space, brings together key voices that are helping to shape these global partnerships. Mike Gold, who now works at Redwire, helped draft the Accords during his time at NASA as Associate Administrator for Space Policy and Partnerships. Mark Jokomich leads the Washington office of the German Aerospace Center, or DLR, supporting Germany's contributions to Artemis through the European Space Agency. Adnan Mohammed El-Rais, Assistant Director General at the Mohammed bin Rashid Space Center in the UAE, oversees the nation's ambitious Moon and Mars programs. And Sohair Salam Saber, president of the Hague Institute for Global Justice, brings a legal and ethical lens, advancing international cooperation through efforts like the Washington Compact, a complementary initiative to the Artemis Accords that invites private industry and civil society to voluntarily commit to shared norms and values in space.
The Artemis program and the Artemis Accords are often confused and run together in a lot of people's minds, and they are separate, of course. The Artemis program continues to evolve somewhat rapidly in recent days and weeks. By the way, you may have noticed on May 15th, Norway joined the 54 other nations that are now part of the Accords. There are now 13 countries that are part of the ILRS, the China-led International Lunar Research Station. Interestingly, we think that Thailand is the only one that is a part of both groups. Interesting position. I want to start our session with the guy who got the Artemis Accords off to a very impressive start. Mike, I'm going to turn things over to you first to tell us about where you think the Accords are and how we got here.
Oh, thank you so much. And 55 is a wonderful number. And numbers do matter, that when it comes to international affairs, establishing norms of behavior, having that number of countries sign the Accords, which has really exceeded every expectation that we initially had, is important. And that success was driven by the inclusivity of the Accords, that we wanted to make sure that the Accords would not be something to separate countries, but to bring them together. We were very focused on common ground. And I want to thank Adnan here and United Arab Emirates, who were a founding member of the Artemis Accords. And I think it's safe to say, possibly more than any other founding member, the UAE really focused on making the Accords as inclusive as possible. That was something the Emirates really strongly brought to the table. And while the Accords were led by America, they really belong as much to the international partners as they do to us. And again, just a wonderful coming together of nations, ideas, and cultures to create something that will support peace and prosperity moving forward. That being said, there is always room for improvement. And I'm as excited about the future of the Accords as I have been the past. And where I would hope to see the Accords evolve is really in two ways. One, while I'm very grateful to the past administration for the support of the Accords, the number of countries that have signed, I have become increasingly concerned that we are beginning to deviate from one of the founding ideas of the Accords, which was for signing the Accords to become a gateway, no pun intended, relative to joining the Artemis program. That it was always meant as a first step to becoming a part of the program. Additionally, we want to see contributions from our partners. And obviously Germany, Emirates are making wonderful contributions, but I'd like to see us be more systematic and more explicit about gaining these contributions. And I think there are large countries like Saudi Arabia, Korea, with great capabilities that have a lot that they could be contributing to the Artemis program at a time when we are budget constrained. And while not entirely the solution, this could be part of the solution to some of the budget issues that we face. And then on the other end of the spectrum, a Ecuador or a Bangladesh that just signed recently, even if it's a couple of grad students, there should be contributions that they can make. The countries want to contribute. They want to participate. They don't want the Accords to be simply a photo op. They want it to lead to something substantive, and I think that benefits us and the Accords signatories. So that's a direction that I hope to see the new administration take the Accords to make it more substantive and to make it more beneficial to all of the parties involved. As we look to the future, I hope that we dig in more to create better specificity with the Accords and actually put meat on the bones of many of the objectives that we've laid out, such as interoperability, such as heritage sites. We all agree we should protect heritage in space just like we do on Earth. But what does that mean? Is it 1 kilometer? Is it 2 kilometers? So this is the work that remains to be done on the Accords. It is an organic and evolving thing as we try and push forward with these ideas. And I'm so excited for the number of countries that are involved, so grateful to the founding countries, and I'm just really looking forward and have never been more optimistic about the future.
So excellent progress and still much more to do. Adnan, we've already heard you introduced as a signatory to the Artemis Accords. I believe congratulations are in order because there was the launch of the UAE's first synthetic aperture radar satellite just very recently. And only a week ago, I saw the announcement that your rover, the Rashid 2 rover, is going to be carried by Firefly Aerospace's next Blue Ghost lander to the moon's far side. Congratulations on that.
Oh, thank you very much, Matt, for that. Thank you for having me here. When it comes to the Mohammed Space Center and BRC, we work on the implementation of the UAE National Space Program. We have the satellite development program, which we develop our Earth observation satellites. As you mentioned, we had earlier the launch of the Mohammed bin Zayed satellite, our next generation Earth observation satellite, earlier this year. And then a couple of weeks later, we launched our first synthetic aperture radar, our SAR mission, as part of our technology know-how transfer program to develop our capabilities and technologies in this area. In addition to that, we continue working on the implementation of the Mars 2117 program, 100 years of strategy to send humans to Mars and building settlement on Mars, and to do that collaboratively with the international community. And in order to do that, we introduced many programs, as you mentioned, the rovers. That's part of our robotics lab, which we want to develop our space robotics capabilities throughout the development of rovers to the surface of the moon and hopefully in the future to the surface of Mars to support the entire infrastructure on the moon and Mars. That's a new capability that we introduced as part of our Mars 2117 strategy. In addition to that, our contribution, the Gateway program with the airlock, and we're going to talk more about that, that's also something in line with the strategy. Working as well with the Human Space Flights program, and having 4 astronauts prepared and ready for the follow-on missions, 2 flown for short duration and long duration mission, and 6 months, and looking for opportunities to send them around Earth and around the Moon as part of the Gateway contribution, and hopefully finding them on the surface of Moon and Mars in the future. We are also developing our life sciences program. And we have a team dedicated working on advancing our capabilities in the human health, how to sustain long duration missions, and working on the life sciences aspects locally and internationally with international partners. Yes, we are developing technologies, but more importantly is development of the human element, the human capabilities, the workforce, the talents, the skilled people that will continue doing that, continue working actively in our contribution and the Artemis Accord.
Well, from a charter member of the Artemis Accords to representative of a nation, an agency that came a little bit later into the Accords, Mark Joachimisch heads the Washington office of the DLR, the German Aerospace Center. Welcome, Mark.
Thank you very much for giving me the opportunity to contribute to the summit and be on this panel. It's a pleasure. And yeah, you mentioned it in your introduction. Germany came relatively late to the Artemis Accords, given its role in space exploration. We joined in September 2023. And ever since then, we really are really happy with the engagement into the Artemis Accords. It's a great forum to discuss and deeper drill into the real questions of safer, more transparent and sustainable deep space exploration. We very much value the knowledgeable contributions from all the countries, and that everyone gets their part in the discussion and can volunteer for taking over different topic items and lead the discussions on those and bring it all together to the whole group. So, and also the interaction with the UN is very, very helpful, and we volunteered to be also a topic leader for that, to make sure the connection between the UN fora and the Artemis Accords and the information flow is going on very well. And so we're really happy with the Artemis Accords as they worked out. And I'm very optimistic that they will continue to grow. And since you mentioned also the program, of course, our engagement in the Artemis program goes much further back than our engagement in the Artemis Accords. Actually, before it was even named Artemis program, the decision to contribute the European service model to or the Orion spacecraft is back then more than 10 years. So the first contract was given by the European Space Agency to Airbus in Bremen in 2014 for the first ESM, which propels the Orion spacecraft and provides life support and energy to the Orion spacecraft. And Germany is contributing more than 50% of that. So this is our biggest contribution to the Artemis program, and we are committed to continue working on that. I just had the opportunity in February to see Orion and ESM2 integrated in KSC, which is a very impressive spacecraft, and it's always fantastic and thrilling to know that the next humans that will go to moon and further out than any human before will be on this fantastic spacecraft. So this is something we want to continue. We also do smaller contributions to the Gateway, and of course we have capabilities in Germany also for bilateral contributions, especially in the areas of space robotics, communication, navigation, and also we had a fantastic panel just here before on astronaut health. So that's something we are looking into and want to keep engaging in a discussion for potential bilateral contributions from Germany to the Artemis program.
And talk about an interoperability challenge, mating that service module to the crew module on Orion. So far, so good. Worked awfully well the first time.
The first time it worked even better than expected.
Yeah. While our topic is the Artemis Accords, you heard Mike talk about where he hopes the Accords will go. I suspect that our two national representatives here may feel the same way. There is an example of at least a piece of where the Accords could go in our last participant on this panel. Lady Soher Salam Saber became president of the Hague Institute for Global Justice in 2018. Soher, welcome and thank you for joining us on the panel.
Thank you. Thank you for having me today here. It's a pleasure being with you. The Hague Institute for Global Justice pillars are three pillars, actually. It's rule of law, global governance, and conflict prevention. And since I became the president for the Hague Institute, we thought that our next decade for the Institute life will focus on future approaches and projects, and space was our first approach to start with as a new decade for the Institute. We wanted to make sure that our pillars implemented in space as well, because we understand the importance for space, not only for space, but also for the Earth. So if you prevent conflict in space, then you save the Earth and you save people, and same as the rule of law and global governance. And that's why we started to draft the Washington Compact, and it's dedicated for the commercial and civil society. I remember the first call I had with Mike, and Kenneth Hodgins actually was there, and we discussed what's the missing in space policies and regulations. It's the commercial, it's the industry itself who drive the future for space. And that's why we started to draft norms of behavior, non-binding document for the commercial and civil society. And because the beauty of the Hague Institute, the neutral position of our institute that can bring everyone from all over the world, from the globe, we thought that having the Washington Compact for the civil society and the commercial sector will bring everyone from all over the world to agree on those principles and standards. So 2022, we started to draft the compact, and really thanks for Mike and for Ken, who work hardly with us to draft and contribute all their time and effort to draft the compact. And by July, we launched the Washington Compact. We started to invite companies. I truly, truly appreciate every single signature we have on the compact, because those people really, and those members who signed the compact, commit with saving the future of the space and saving their investments as well, because by signing the Washington Compact, by signing the norms of behavior and standards and principles, you are also saving your investment, your future, and your company, and your operation, and your organization. So for now, we're having over 200 signatories on the Washington Compact, which is really a milestone in just 2.5 years. It's still by invitation. And as I said, last January, it was a milestone for the Washington Compact to have the spaceports to come on board and sign the Washington Compact. Now, there is really a link between the Washington Compact and the Artemis Accords. So the Artemis Accords, you have 55 countries who sign it, which is great achievement and really great effort also from Mike and all the team to bring those countries to sign the Artemis Accords. But the Artemis Accords is for states and for countries. So still, the commercial sector and civil society is not there, and their voice is not there. And that's why we have the Washington Compact, which can complement the Artemis Accord and complement all other, let's say, also the other treaty, which is the UN treaty. But for the future, having the Washington Compact for commercial sector and for civil society will definitely be a complementary to the Artemis Accord future as well.
And I encourage everyone to go to the Institute site to see that list of over 200 signatories now and read the text of the compact, because I found it inspiring. Mike, I suspect you do too, and is that partly why you wanted to be part of this?
Absolutely. I mean, Lady Sahara had incredible vision and leadership, and let me live out my unfinished dream with the Accords, because we had a clock on us with the Artemis Accords and couldn't necessarily be comprehensive. And as Sohair points out, the challenge that we've got in international space law and policy is the system simply was not built for the current reality of private sector leadership. At the United Nations, there is no chair for the private sector, yet it is commercial space that is driving so much of the change and the substance. So we have a mismatch there. And that's where the Washington Compact and the work that has been done is so important, because through NGOs like Sohair's and through work like the Washington Compact, it's the first time that the private sector can have a seat, and a seat that's equal to government in determining the rules of the road. And that is necessary for success. The private sector has most, or at least much, of the experience, and bad regulations come when people who don't have the substantive experience are writing the rules. So again, I can't applaud what Sohair and the team has done enough. That is the future, I believe, of space norms, law, and policy.
Back to the Accords and the relationship with the Artemis program, which we can't really avoid, the elephant in the room. I talked about how the Artemis program is evolving very quickly. And we have here representatives of two nations that have a big part in both. Adnan, the development of the airlock module for the gateway. Will there be a gateway? And if it does not happen, does that affect the participation of the UAE, not just in the Artemis program, but in possibly more broadly in the Accords?
Yeah, so first of all, we're happy to be part of the Artemis program with the contribution with the airlock module for the gateway itself. For us, it was an important program which helps in implementation of our strategy, but also to be a key player internationally, working with international partners to make this a reality and sending human back to the moon again and hopefully to Mars. For us, it's strategically important to develop also our capabilities in terms of the development human-rated systems. With all the missions that we developed, with the orbiters, satellites, rovers, and so on, and manned missions. So with the airlock development as part of the gateway, this is one of the strategic goals, to develop our capabilities in this area so that we can even further contribute in the future programs and future contributions. Yes, we understand the process, we understand the budget request that came out and potential cancellation of the gateway program. This is the process, again, we fully understand, we fully respect as well. It has to go through. I think it's also healthy as well to revisit your programs, to revisit your architecture and the way that you develop the missions. One thing that's for sure for us that we are fully committed to work together with the United States and the international partners on the implementation of the program. With the gateway, with the airlock, which we hope that they're going to continue. Having the gateway is an important element. However, beyond that, we are here fully committed to look into the future contributions, future involvement, future engagement, because you have a lot of pieces there. You know, you have a lot of elements related to the infrastructure on the surface of the moon, the habitation, the human element, and all of that. There are many areas that we are interested in, and we can contribute in future program elements.
Mark, I'd like you to address the same. What I have in mind, again, it's Artemis program. Orion seems to be good through Artemis 3. We're not sure about after that.
Yes, Adnan put it very well. Every program goes through development. So on the way, you need to make adjustments to stay focused on your target. That's normal. The whole overall Moon-to-Mars architecture by NASA is constantly evolving. There's a regular update every year with workshops and international partners coming in. So this is kind of natural. So in an ideal world, all the partners are on the table to discuss those changes. And like Adnan said, Germany stays fully committed to what we agreed upon to contribute to Artemis. And we want to be part of the program. We want to continue working with the US, with all the other international partners in Artemis. And we are ready to do so. And as you said, for Artemis 2 and 3, it seems we're sticking to the original plan. We have to see what comes after that, what alternatives are there, if we need to adjust the program, and how our contribution, which of course involves a long-term investment also on the European side for all the ESMs that are lined up and industry partners that have invested into that, how we can find a way to keep this cooperation going while having our common goal and target in focus and in mind to bring humanity back to the lunar surface, and of course to learn from all our experiences there and all the technology development we do there for the exploration of Mars.
Mike, I'm not even sure how to refer to the relationship between the two, but there's the Artemis Accords, and as I said, there's the ILRS, the China-led International Lunar Research Station, ILRS, yes. It's difficult to look at that and not see it as something of a competing program. How do you see the relationship between the two?
So I do see a competition of ideas. I see a competition of values. And I think it's important that we not just launch our astronauts to space, but we launch our values of transparency, of open science, of peace, of the ability to extract resources and enjoy the fruits of your labor, of avoiding conflict. We need to preserve these values, and it is important that we lead not just in technology, but in policy. And candidly, much of what is in the Accords is a reaction to things that some other nations may not have been practicing. So that's why numbers matter. That's why the more countries that sign, the more countries that create momentum and precedent for doing things the right way, the better off we will be. And even for countries that don't sign the Accords, like many of the ILRS nations, they will be influenced by the positive practices that the Accords support. And that even those countries, again, that haven't become a part of the Accords will be influenced by what we're doing, and the Accords can serve as catalyst for additional conversations like the Washington Compact that take these values further, more broadly, and empower the private sector.
Lady Sohail, that's exactly where I was hoping to go. That whether you believe that the compact, even though the signatories are not nations, also may help to set an example with this really important point that Mike has made about the Artemis Accords.
Yeah, it definitely said committing with values and with principles that sustain and make the industry itself more certain for the future, then the whole country will be more certain, and the whole country the nation will be more sustainable. So values are very important. As Mike said, we don't only take technology to space, we take also the value to space. So it's very important. Now you have a great competition between different countries who wants to set different programs, and how this competition will play a role, where the commercial sector will be among this. If I like what Ken is always saying, if you are a commercial sector and you are not part, or your country is not part of the Artemis Accord and not part of the Chinese program, then where you fit. It's a great competition. Maybe you don't feel it now, you don't see it now, but it will be in the future bigger. I really hope that the United States keep leading the space industry, because the United States not only leading the technology, but also policies and regulations and rule of law. And they really prevented conflict for space for the last many years, and I hope that they continue this. With the news we are hearing now, having the Space Council again in place, that's a great indication that policies will continue to be improved and implemented, which will help the commercial sector and help the civil society as well. I hope that the Artemis Accord continue to be improved and to be beyond the Artemis program. That's how you can improve it more and get the whole world together, because it's the latest non-binding or the latest document to be signed with those nations. So it's great that it continue and it go beyond to more and more than the Artemis program itself.
Adnan and Mark, I want to see if you have anything to add. Your hopes, your nation's hopes, for the principles behind the Artemis Accord, seeing them develop in the way we've heard discussed already. Adnan?
Yeah, I totally agree with Mike. The Artemis Accord is the gateway to be part of the program and to get involved and to have also kind of tangible contribution in any capacity. But also it provides hope. It provides opportunities for nations that are maybe not ready today to contribute, to dream, to work on that as part of their education outreach, preparing maybe the next generation that could play a bigger role in the program. I think it's important that the Artemis Accords is inclusive, having those great nations part of the Artemis important. It's important as well to conduct those kind of workshops to identify clearly the contributions and how we coordinate the contributions between the different nations to reach that interoperability, which is a very, very important element. And here, we need to focus on the development of the standardization. Maybe there's something that we're lacking here in the space sector, that we need to further develop the standardization to be able to work together on development of the entire architecture.
Mark?
I can only second that. I was impressed how active, how outspoken some of the, let's say, non-traditional space countries that are part of the Artemis Accords engage into the discussion. And there was a lot of feedback from their side that joining the Artemis Accords and being part now of this group was very instrumental internally in their process to set up, to gain more resources for their space activities. So this is something that's definitely an added value of the Accords, besides talking about the rules and the rules of the road and everything we want to solve when it comes to deep space exploration. So I think this is very inspirational, and so this should continue, and I'm sure it will continue, and therefore adding even more countries, and also those that are, as you said, cannot right now participate in the actual program with substantial contributions, is really, really worthwhile to do so.
Please help me thank them for joining us here on the H2M2 stage.
As we look toward humanity's future on the moon and Mars, we hope that journey continues to be shaped by people like those who we've heard from today. People working not just to get us there, but to ensure that we do it together, ethically, and with a long-term vision that includes all of Earth's nations. The path to space should reflect the very best of who we are. Now it's time for What's Up with our chief scientist, Dr. Bruce Betts. Hey, Bruce.
Hey, Sarah.
Wanted to say congratulations on your son's wedding coming up soon.
Thank you. I mean, I don't want to take the credit for it, but we're very happy about it. Just found a wonderful woman, and they've been together for a while, and it's all wonderful, and I love it. Thank you.
As much as we want to talk about going off to Mars and the moon and all those places, right? I think it's important to remember, like, we're all human and so much of our human lives happen here. And I am just so happy for you guys.
Well, you're nice, but then we knew that. They're nice too. Not everyone's like me.
But so, this week we're talking about Matt's adventure to the humans to Mars and the Moon Summit. They changed the title a little bit this time because of this Moon to Mars architecture. But as we've seen in this presidential budget request, a lot of those plans are changing. And part of that is that they're thinking about canceling the Lunar Gateway space station. So if that's canceled, what do you think are some of the technical implications for getting people to the Moon and Mars, knowing that that was already a really hard thing to do?
That's for sure. Well, I think it affects what you do at the Moon. So if you have a stable space station equivalent in going around the Moon, which is, once you get it built, not that different than space station going around Earth, although you do have higher radiation and other details. Then you have communications, you have a place to go to and from the surface. So in the end, I don't know, it's speculation. I'm terrible at guessing the future, but it seems like it's going to limit your missions to the surface and also take away some of what you might have learned that might have been relevant about going to Mars, involving everything from docking to long duration exposure and space flight. Yeah. So, and you're going to do a lot of your operations on the surface of the Moon instead of a combination. There's always been ideas, at least floated in Planetary Society, people associated with this. If you go to Mars, you may want to leave things in orbit there, or even, I don't know politically you'd ever be able to go there and not land the first time. But one of the really hard and dangerous thing, well, that isn't true, but one of many hard and dangerous things of going to Mars is trying to land. It's like the hardest place in the solar system to land that has a surface, because you have just enough atmosphere to cause problems and make it challenging. And so how you land something human scale, meaning you have to have a lot of mass to keep those humans alive, is tricky. Anyway, it certainly changes things. It also has negative effects. That we've got relationships with ESA and other international space agencies, that this was one of the places we were going to have serious collaboration. And so that going away throws that all up in the air and leaves them hanging.
Yeah, especially in a day after the International Space Station might be crashed into the ocean. We're going to have limited space stations up there in which we can have this kind of international collaboration. And I do worry, too, that if we also cut things like Mars sample return, which was kind of our first attempt to bring things back from Mars, like, how are you going to bring humans back from Mars if you can't even do it with rocks?
Oh, will they come back?
I mean, that's something we have to consider, right?
No, I know people do, but no, that's true. And again, as a reminder for those who haven't thought about it much, Mars is a lot harder to do than the Moon with humans, because of the landing challenges, because of the long duration space flight getting there, the long missions, the radiation exposure, the in terms of the spacecraft going there. It's just a big mess. Communications, it's non-real time. When you're at Mars, you're several minutes round trip communication time, whereas the Moon, you got a second and a half, and so it's just like a bad phone connection.
I mean, there's still ways that we can send humans to Mars without the gateway, but I do think that it would make it a lot easier if we had that as a staging ground and then focused on people on the Moon for a little while, at least until we learn how to build permanent settlements off of Earth, and then send people to Mars. But there's still ways to do it if we have enough funding to do it, which I am also skeptical of.
There's also a question whether you do permanent settlements. I mean, that's some organizations are big fans of that. Planetary Society has not always been that way, isn't particularly that way. It's more about the exploration and doing it. Because when you get into permanent settlements, that budget goes way up, and you end up very bogged down if you want to go to Mars and you're going to the moon, and you've set up to set up the infrastructure for that is truly a monumental task and much more challenging than the Gateway. There are all sorts of scary things that might be cut in this budget, or disturbing things, I should say. They're not scary. They're just, they hurt, Sarah.
Yeah. But hey, maybe if we don't get it right this time, in 100 years, there'll be geologists on Mars picking up rocks and bringing them back for us. So what's our random space fact this week?
Well, the random space fact, the Vera Rubin telescope that's just seen first light in Chile and has amazing images you can find online, has one of the world's largest digital cameras, certainly the largest one ever constructed for astronomy. It's about the size of a small car and weighs almost 2,800 kilograms or 6,200 pounds. The focal plane has 189 CCD sensors arranged on 21 rafts for a combined 3.2 gigapixels.
That's a lot of pixels.
If they do that in one night, they will shoot the equivalent their deep sky surveys of so a regular digital camera, let's say 8 megapixels, it's the equivalent in one night of 800,000 8 megapixel digital camera images.
That explains why those images are so beautiful. That's unreal.
And huge. Yeah. No, they use this amazing giant camera built by SLAC, in Stanford. It used to be the Stanford Linear Accelerator Center, but they built this beast, and then it got incorporated into the telescope, and it's amazing. The images are beautiful, and so we have so much to look forward to in deep space astronomy, cosmology, and finding lots of stuff in the solar system,
including asteroids and things like that. We had a previous conversation with some people that were creating a new algorithm for the Rubin telescope to do exactly that. But I'm hoping, and I have connected with the Vera C. Rubin Observatory team to hopefully bring them onto the show and talk a little bit more about it now that we've got first images, because my gosh, that Virgo cluster, that was nuts.
That's just such a wonderfully nerdy, happy thing you just said. That really Virgo cluster. It's nuts.
I mean, did you see that picture of the three galaxies all collide? That was so cool.
No, it's very, very cool. I'm not making fun of it. It's wonderfully nutsy, crazy, those images and what they're going to obtain of the whole sky, and I'm sure it will be a source of random space facts into the future because of its technological awesomeness as well as what they're finding.
Right.
Okay, everybody, look up in the night sky and think about the night sky. Think about what's out there. Go look at the Virgo cluster. Look at their deep survey from just their first set of data, and you'll get an idea of there's a lot of stuff out there. So much. Anyway, thank you and good night.
We've reached the end of this week's episode of Planetary Radio, but we'll be back next week to learn more about the Vera C. Rubin Observatory's gorgeous first images. If you love the show, you can get Planetary Radio t-shirts at planetary.org/shop, along with lots of other cool spacey merchandise. Help others discover the passion, beauty, and joy of space science and exploration by leaving a review and a rating on platforms like Apple Podcasts and Spotify. Your feedback not only brightens our day, but helps other curious minds find their place in space through Planetary Radio. You can also send us your space thoughts, questions, and poetry at our email, planetaryradio@planetary.org. Or if you're a Planetary Society member, leave a comment in the Planetary Radio space in our member community app. Planetary Radio is produced by the Planetary Society in Pasadena, California, and is made possible by our members all around the world. You can join us in advocating for and educating about the missions that will return us to the moon and carry us onto Mars at planetary.org/join. Mark Hilverda and Ray Paoletta are our associate producers. Casey Dreyer is the host of our monthly Space Policy Edition. Andrew Lucas is our audio editor. Josh Doyle composed our theme, which is arranged and performed by Peter Schlosser. And until next week, Ad Astra.